And I wanted to do a quick video on completing the square using the method we learned in class with the, like using the boxes and doing the whole multiplying by 4a thing. So I know I've linked some other videos on the video page, but it doesn't do the method that we learned in class. The method that is on that video page is what I'm used to doing, like that's how we learned in school. But these are neat methods too. Okay, so I'm going to start with a problem that looks like this. So we have x squared plus 12x plus 10 equals 0. So the whole idea behind completing the square is we want x plus or minus some number in parentheses squared equals some other number. And if we have our binomial squared equaling another number, then what we can do is we can take the square root of each side and end up with x minus p equals plus or minus square root of q, and then we just add the p over, and we have our two answers. So this is an easier thing to solve than this. Like we want to get it down to where we just have the one x instead of having two. So, and again, this is one that we probably could, maybe not. Never mind. I was going to say this is one that we could factor, but I don't think we actually can. All right, so what we're going to do is, because I can't factor this, because nothing that multiplies to give me 10 adds to give me 12, I'm going to subtract my 10 from both sides. And then I'm going to do x squared plus 12x, and where that 10 was, I'm going, 12x. Where that 10 was, I'm going to put a little box, equals negative 10 plus, and then if I add something to the left, I have to add it to the right. And then what I want is some number that allows me to do x something squared. So I need some number to go in here, but if I put a number over here, I also have to put it on this side. Okay, so what I'm going to do is I'm going to come over here and draw my little factor box. And the first thing I want to do is check to see if this is even, and it is. So this is even, and the number in front of x squared, there isn't one, so we're fine. So this is even, which means I can cut it in half. All right, so I'm going to put the x squared here, or this x squared here, I guess. And normally whatever is in this box is what goes in here. Well, I don't have anything, so we're going to use the box to get this last corner and then use it to fill in these two boxes. All right, so I'm going to take my 12 and I'm going to cut it in half. And that's 6. So I'm going to put a 6x here and another 6x here. All right, and then I'm going to factor this, and the goal is to have this side and this side be exactly the same. So what can I divide, or what's the square root of x squared? Well, it's just x. And then x times something gives me 6x. Well, that something is 6. So x times 6 gives me 6x. X times 6 gives me 6x. So these are my two factors, and these are positive 6's. So those are my two factors. And now I just need this box. Well, remember we're doing x times x, 6 times x, x times 6. And so this is 6 times 6, which is 36. So I'm going to add 36 to each side of my equation. Now I have x plus 6 times x plus 6, which is x plus 6 squared. On this side, I have negative 10 plus 36. Well, if I add that, that gives me 26. All right, so now this is in this format. So I can start solving. So I'm going to take the square root of each side. And when I do that, I'm left with x plus 6, because these cancel, equals positive or negative square root of 26. Now you cannot take the square root of 26. I mean, you can, it's going to be irrational, so we're going to just leave it like this. And then I'm going to get x by itself by subtracting 6 from each side. And my final answer is x equals negative 6 plus or minus the square root of 26. Okay, so that's not that bad. It's a little strange, but it's not bad. Okay, so what happens if my middle term is odd? So let's look at one like that. We have x squared plus 5x minus 12 equals 0. Okay, so the first thing I want to do is move my 12 over. And that gives me x squared plus 5x plus my box equals 12 plus my box. Now, oh, y'all can't even see that. Okay. All right. So I could go straight into this, but what I would have to do is cut this in half. That's going to be 5 over 2. And then when I go to factor that, that's going to be 5 over 2 and 5 over 2. And when I multiply 5 over 2 times 5 over 2, we're going to get like 25 over 4. And that's just, that sounds miserable to work with. Like, I don't want to work with that at all. I don't want to work with a fraction. You can, but I don't want to. So, what can I do to avoid working with fractions? Well, I can multiply everything by 4. Now, I could multiply by 2, and that would give me something even, but then the number in front of x squared isn't a perfect square. So then I would have to figure out, well, what's going to give me a perfect square, and that's going to be kind of a pain in the butt. So I don't want to do that. So I'm going to multiply by 4. So 4 is a perfect square, and then it's also even, so this will force this to become even. And again, this is not something I ever learned in school. This is a new method to me, but it makes it so much easier than trying to force a fraction. So we're going to distribute the 4 to all the numbers. We're not going to worry about the boxes because there's nothing in there yet. And I don't want to, once I figure it out down here, well, once I figure it out with my box, I've already multiplied by 4 with these. So that makes my box numbers a little bit easier. Okay, so we're going to go ahead and multiply that out. So that's 4x squared plus 20x plus our box equals 12 plus our box. So I'm going to come back over to the side. We're going to make our box. All right, first term goes in the first box. And then we're going to take this term and cut it in half. And that becomes 10x and 10x. All right. So the first thing I want to do is take the square root of this. So the square root of 4 is 2, and the square root of x squared is x. So this is 2x times 2x. All right, so 2x times something gives me 10x. Well, that something is 5. And then 2x times 5 also gives me 10x here, so we have a 5 here as well. And again, the whole goal is we want these two things to be the same so that we can square it at the top like we did here. All right, so 2x and 2x is 4x squared, 2x and 5 is 10x, 2x and 5 is 10x, and 5 and 5 is 25. So that 25 is what I'm going to put in these boxes. Okay, so this is the same thing as this times this, and anything times itself is squared, so that's 2x plus 5 squared, equals, we're going to add these two together, 12 plus 25 is 37. All right. I messed something up real quick. I multiplied by 4. I never multiplied the 12 by 4. 12 times 4 is 48. So that's not 37. 48 plus 25 is 73. I was about to say, wait a minute, my key is not right. All right, so now to finish this off, we're going to take the square root of each side. These cancel, and I'm left with 2x plus 5 equals the square root, positive or negative square root 73. We have to remember that positive negative, because when you take the square root, you know, if you take the square root, two positives make a positive, but also two negatives. So a positive number squared gives me a positive number, and a negative number squared can also give me that same positive number. So we want to make sure we include both possibilities. Okay, then we need to get the x by itself. We're going to subtract 5 from each side, and that gives me 2x equals negative 5 plus or minus the square root of 73. And then we can divide both sides by 2, and x is equal to negative 5 plus or minus the square root of 73 over 2. Okay, and then that's my final answer. Now, one thing I do want to mention is if you are on IXL, or even if you're like on the LEAP test, it may ask you for both solutions. And that's why we have a positive negative. We have two solutions. So one solution is negative 5 plus the square root of 73 divided by 2. The other solution is negative 5 minus the square root of 73 divided by 2. And then sometimes I'll ask you for it in decimal form. You can just put this straight up in the calculator. Take the square root of 73 minus 5, divide it by 2. Over here, take the square root of 73, make it negative, then minus 5, divided by 2. So you can put both of those in the calculator, get your answer. Okay, I want to do one more that has maybe a number in front of the x squared. And then that'll be the last one I do. I'm just trying to find an example where, here we go, here's a good one. Trying to find an example that's not super, super messy. Okay. Going to take this. All right, so let's say we have a term in front of the x squared. So we have 2x squared minus 20x plus 47 equals 0. Okay, so same skills. We're going to subtract the 47. Same skills, same steps, I mean. And then that leaves us with 2x squared minus 20x. We're going to put our placeholder box here, equals negative 47 plus our box. All right. Okay, so we do have an even number here, so we can cut it in half, but this is not a perfect square, so I can't take the square root without it being like an ugly irrational number. You could divide by 2, but this is odd, so that's going to give us another fraction, and I don't want to deal with that either. So we got to look for something that we can multiply that will give us a perfect square. So you can multiply this whole thing by 2. That would make this a 4. That would make this a 40. This would be an even number. Something you can always do though, if you're struggling to figure out what to multiply by to make this an even number and this a perfect square, you can always multiply by 4a. Like this is one that I can multiply by 2 and it would be an easy way to do it, but I don't want to just say, oh, look at it. I want to give you something that you can always do. You can always multiply by 4a and it will always work because it will force a perfect square, because you're squaring this term and then you're multiplying by 4, which is going to make everything even. So, and 4 is another perfect square, so you'll be able to take square roots. And it be rational. So that's an always something you can do. So we're going to do that, even though you could multiply by 4 and it might be a little bit easier. So if I wanted to multiply by 4a, we're going to multiply by 4 and then whatever's in front of the x squared is my a value. So 4 and 2. All right, so 4 times 2 is 8. So we're going to multiply everything by 8. Okay, so 8 times 2 is 16. So this is 16 x squared minus 160x plus a box equals. Ooh, let me find my phone real quick so I can tell you exactly. We're going to do 47, make it negative, times 8. Negative 376. Plus a box. Okay, so let's come over here and fill in our factors. We know we've got our 16x squared over here. We're going to cut 160 in half, and that should be negative 80x. And this is a negative, so we want to make sure that this is negative. And then we're going to figure this box out. So we're going to take the square root. The square root of 16 is 4. The square root of x squared is x. So we have 4x and 4x. Okay, so 4x times something gives me negative 80x. That something is negative 20. So 4 times negative 20 is negative 80. All right. This should also be negative 20 because negative 20 times 4 is negative 80. And then we've got to figure out this box right here. Negative 20 times negative 20 is going to be positive 400. So we're going to fill in these boxes with 400. Okay. All right, so this factored. These are our factors. So this is 4x minus 20 squared equals 400 plus negative 376. So I have this. So plus 400. That is 24. Okay. So we need to get rid of the squared. We're going to cancel that. We're left with 4x minus 20 equals plus minus the square root of 24. Okay, and now it's just solving a simple equation. We're going to add the 20 to each side. That gives me 4x equals 20 plus or minus the square root of 24. Then we're going to divide both sides by 4. And that gives me x equals, and we'll just leave it as 20 plus or minus the square root of 24 over 4. All right, and to be clear, this is not the most simplified version of this. You could divide the 20 by 4 and then leave this as square root 24 over 4. You can also simplify the radical, but that is an Algebra 2 standard. I used to teach it, but we ain't got that kind of time anymore, so I don't do it as often. I wish we could, but I can't. All right, so This is the box method, 4A method for completing the square. I hope this was helpful. Check out the other videos on the video page if you prefer the old-fashioned fraction way. But I also know my babies, and I know how fractions give you the heebie-jeebies. So, hope this video was helpful. Hope you guys have a great evening. Take care. I will see you in class.